So I want to do a very quick run through of electronegativity and how that affects the covalent bonds that we have inside molecules. Because one of the skills that you're going to need to have in Chapter 2 is to be able to identify whether covalent bonds are polar versus nonpolar. So just really quickly, remember that electronegativity, that's really the strength that a particular atom has for the electrons that surround it. And we have atoms that are very strong. And so that means that they pull very strongly on any electrons that they happen to be sharing. And then we have others that are very weak, meaning that they don't pull very hard on those electrons. So you can think of the strong ones as the really muscular, big guys, and the weak ones as the ones, they're just not very strong at all. So we think of them as just being kind of small, and they would lose if they were involved in a tug of war. So if we give examples of the atoms that we're going to be looking at that are going to be very strong, our big strong ones that we're going to see a whole lot this semester are oxygen and nitrogen. So anytime you see those two, we want to think of them as very strong, kind of muscular atoms. They're going to be pulling on the electrons with a lot of strength. And then our weak ones are going to be carbon and hydrogen. So they won't be able to pull very hard at all. So they're going to lose if they're in a tug of war with a really strong guy like oxygen and nitrogen. So if we talk about the polar versus the nonpolar covalent bonds, the polar ones, so polar covalent bonds, those are the ones where you have somebody that is strong and they are sharing with somebody that is weak. And that means that the electrons are going to get shifted or pulled more towards the strong one. And if we talk about the nonpolar covalent bonds, that's going to be just the opposite, because the nonpolar covalent bonds, that's when we have an equal match. And by an equal match, we're saying that we're going to have either a weak one that's trying to share with a weak one, or we're going to have a strong one that's sharing with a strong one. Okay, so if we look at our example here really quickly and we label these bonds as being either polar or nonpolar, if we look first at this bond between the hydrogen and the oxygen, remember that oxygen is strong and hydrogen is weak. So I'm just drawing an S and a W on there for that. And if that's the case, that means that the strong one's going to be kind of winning. So the electrons are going to be much closer to the oxygen end. So I'm just going to draw them in like that. And if that is the case, then that would be an example of a polar covalent bond, because the polar covalent bond is when we have that unequal sharing. If we look right here, we're going to have the same situation because the carbon is weak and the oxygen is strong. So again, oxygen is going to have those electrons much closer to it, and that's going to lead us to another polar covalent bond here. So if we just go through and we label the rest of these atoms as either being strong or weak, hydrogens are weak, and I'm just going to put a little W on all of my hydrogens here. We already said that the carbons are weak, and then the nitrogen is one of our strong examples. So if we look at these, if it's weak and weak, they're going to share equally. The electrons are right in the middle. So if the electrons are right in the middle, they're sharing equally. That is nonpolar. We would have the same situation here because they're sharing equally. So that's another nonpolar covalent bond. This one and this one, another nonpolar. Again, two weak ones sharing with each other would be nonpolar. In this case, the carbon with the hydrogen is also nonpolar. And now when we get right here, we have an example, the nitrogen is strong, the carbon is weak. So the nitrogen is going to be pulling those electrons towards it. If that is the case, then that will be a polar covalent bond. And then if we just look at the other two bonds that we have, they are also going to be polar covalent bonds because, again, you have a strong one, the nitrogen, that is sharing with the two hydrogens. So those will both be polar. Okay, so that's a quick run through of how we look at specific covalent bonds, and we determine whether they are going to be polar covalent bonds and nonpolar covalent bonds.